Assalamualaikum warahmatullahi wabarakatuh. We are from Ocho and we need to explain about unfairness. Next slide. Okay, unfairness is obviously the absence of fairness. So what causes unfairness? The causes of unfairness is indefinite postponement, which can be known as starvation. So what is starvation? Starvation is multitasking system always switches between the first two tasks while the third never gets to run. So this can be seen as unfairness, which not all tasks can run. So what is the solution for the unfairness? The solution is fairness, where all trades should be advancing their work in almost equal portions so that all tasks can doing their tasks until the end.
Review the paper 1. So the title is the thread lock section aware scheduling on asymmetric single ISA multi-core. So the problem is that more applications become multi-threaded, causing growing number of threads executing on a machine. So the operating system will require increasingly larger amount of CPU time to schedule this thread efficiently. So the solution it proposed is to identify multi-thread application bottlenecks such as thread synchronization that complements the fairness aware scheduler method. So the method that we use is the thread lock section aware scheduling policy, which influenced by the fairness aware scheduling to reduce thread serialization and improving parallel thread performance.
Okay, next we will review for paper 2. For paper 2, we have the problem which is the round robin based packet scheduler have a low complexity and do not support short-term fairness. While for the solution and method that we will implement for this paper, which is the fair round robin method to overcome this limitation. This fair round robin offer for better short-term fairness than stratified round robin, or known as STRR, and others existing round robin schedulers.
So as the conclusion, we choose to use paper 1, which is log, as our solution.
Okay, so hello. Today I will be explaining about the unfairness in our code. So this is the smart gate class, where inside it we have the main method. Main method is the method that will be run once the code start to execute. Okay. Next we have the end array of the detected entity object. What is detected entity? The detected entity represents a person detected at the main entrance. So inside detected entity, we will have 3 data, which are metric number, pulse rate, and temperature. These 3 data will be used later for data processing. So this is to indicate that we have 4 persons detected at the main entrance. Okay, so this line of code will indicate the trade creation. Why we use the multi-trading concept is because we want to show that many persons can arrive at the main entrance at the same time. So each data processing should be done concurrently. The best way to solve this is by using the multi-threading. So this line of code indicates the arrival time of each person. So there are 3 persons that arrive at the same time and 1 person that arrive later. So when the start method is triggered, it will run the run method inside this class. Okay, so the run method will be used to initiate the data processing. So this is to indicate which person is detected first at the main entrance. So it will print the order of the person. This somehow to prioritize the person who is detected first. So once after the person is detected, it will execute the get result method. It will start the data processing by triggering this method. So inside it, we have the thread.sleep. The thread sleep method. We use this to pass the current thread to pass the execution of the current thread. This is to prevent that there are many threads accessing the shared resources at the same time. Okay, so we have the start. Start indicate the start of the execution trade. The trade execution. X indicate the pulse rate and T indicate the get temperature. Okay, so here is where the trade start to acquire resource. Okay, so here we have the condition is if pulse rate is between 40 and 100 BPM, the temperature is between 36.5 degrees Celsius and 37.5 degrees Celsius, the person will get the entry permission. Else, the person will not be permitted to enter the door. Okay. So, N indicate the end time of the execution. So this is to calculate the duration of the trade execution. So here is where the data processing is finished. To indicate the data processing is finished, it will print the runtime, temperature, degree Celsius, pulse rate, and the result. And after that, it will stop. So here is the output. Okay, so here, the output show that person 1, 2, and 3 arrive at the same time, while person 4 arrive later. This is the same with what I have mentioned before. Okay, so as we know that unfairness is the absence of fairness. What is fairness? Fairness is the policy in Java that takes the waiting time of a trade to indicate which trade should be the next to acquire the resource. So here, as I am showing you the execution of the unfairness code, we can see that even person 4 arrived later, but person 4 is the one who get the permission to acquire resource. This is unfair because the 3 person that arrive first wait for their turn to acquire the resource to get through the door, but person 4 is the one who get the data processing finished first. Okay, and later we can see that the order is 213. It doesn't follow this order of trade request. Okay, so this is where we indicate the unfairness in the system, because if we follow the fairness policy in the Java, the execution, the data processing should be done according to this order. Okay, so to prevent unfairness from happening inside our system, we decided to apply the reentrant lock. Reentrant lock is a lock that apply the fair ordering policy. So here is where we call open the lock. If the lock returns available, then the trade that access the lock will be permitted to enter this section. Else, if the lock returns unavailable, then the trade that access the lock will be put to disable mode. It means that it cannot proceed until the trade that execute this section release the lock. Okay, so we will see the output of the reentrant lock. Okay, so this is the output of the fairness policy which we use the reentrant lock. Okay, so these indicate that there are 3 person arrive at the main entrance, which is person 1, person 3, and person 2. Okay, so this indicates the person that arrived later. So the order is 1, 3, 2, and 4. So as we can see here, the output is printed according to the order, the trade request order. So here we can see that the system already applied the fairness inside the code. So you can see that the first trade that requests for the lock will get the lock first. It means that it will use the first in first out concept.